Let's go ahead for maths. It's the whole of integration in the higher maths 2023 exams. That includes integrating a polynomial or trig function, chain rule differential equations, finding areas using integration, and some hard, strange questions. Let's get started. Integrating a polynomial. SQA Higher Maths 2019, paper 2, question 2. Integrate this polynomial. So we need to get it ready to integrate, just like with differentiation. So I'm going to change that to the integral of 6x to the half minus 4x to the minus 3 plus 5, and then we can integrate because we add 1 to the power and divide by the new power. So that gives me x to the 3 halves, still times 6, but that's divided by 3 halves. We'll deal with that later. And then minus 4x to the minus 2, minus 3 add 1 is minus 2, so divide by minus 2. Then plus 5x, and then remember to add your c. Okay, dividing by a fraction is the same as times by its reciprocal, so I can just do 6 times 2 is 12, so that's 12 over 3. X to the 3 halves. 4 divided by 2 is 2, minus divided by a minus is a plus, so plus 2x to the minus 2, plus 5x, plus c. 12 divided by 3 is 4, so that's 4x to the 3 over 2. Plus 2x to the minus 2 plus 5x plus c. And you will get your final mark at that stage, but let's just assume you wanted to go further because you're going to use it in another question. This helps us revise indices. So we've got x to the 3 halves. So that's the same as x, the square root, because of the 2, x cubed, plus 2, x to the minus 2 over x squared, plus 5x plus c. But you don't need to go that far for this question.
Question 6. A curve of equation y equals f of x is such that dy by dx is 1 minus 3 over x squared, where x is greater than 0, of course. Curve passes through point 36, express y in terms of x. So if we just integrate, then we'll get y equals the integral of 1 minus 3 x squared on the bottom, so x to the minus 2 dx. So we add 1 to the power and divide by the new power, so that means that y equals x minus 3 over minus 1, x to the minus 1, but then we've got plus c. So tidy that up, y equals x plus 3 over x plus c. So we're going to have to work out c, but we're given a point 36, so we can just substitute that in. So at 3, 6, we've got that's our x and that's our y, remember. So 6 equals 3 plus 3 over 3 plus c. 6 equals 3 plus 1 plus c. 6 equals 4 plus c. So it's easy to see that c must be 2. So to answer the question, y equals x plus 3 over x plus 2.
Integrating a trig function, which also ties in with the chain rule. So we've got SQA Higher Maths 2015, paper 2, question 7. Part A, find the integral of 3 cos 2x add 1. So we've got the integral of 3 cos 2x plus 1 dx. You don't need to give yourself a headache here. Check the start of the exam paper, it tells you if you integrate cos, you get sine. So I know what that's going to give me sine. So we've got 3 sine 2x. The 1 integrates to x, but we'll get there in a minute because you need to be careful here. This is not cos x, it's cos 2x, so the chain will apply. So you differentiate 2x to get 2, and you then divide by it. So it's divided by 2. And now I can integrate the 1, so it's plus x, and then I've got a plus c on the end. So just tidying that up a little bit, I could write that as 3 over 2 sine 2x plus x plus c. And we're done there. Part B says, show that 3 cos 2x add 1 equals 4 cos squared x minus 2 sine squared x. So it's a trigonometric question. We have to use our cos 2x expansion from the start of the exam paper. So part B, 3 cos 2x plus 1. I'm going to try and make that look like the right hand side. So cos 2x, I'm going to expand to cos squared x minus sine squared x. And that's still plus 1. So that's 3 cos squared x minus 3 sine squared x plus 1. Let's see what we're trying to make it look like. Well, there's no actual 1 in the question, so we're going to change 1 in a funny way, because 1 is sine squared x plus cos squared x. So taking that 1 out, we get 3 cos squared x minus 3 sine squared x plus sine squared x plus cos squared x. 3 cos squared x plus cos squared x is 4 cos squared x, and minus 3 plus 1 is minus 2 sine squared x. And we should be done there. Okay, part C, integrate sine squared x minus 2 cos squared x dx. We're going to use our result that we've just found out, because that looks very similar to this result. So let's have a look at what this result was. It was 3 cos 2x add 1. So as an aside, 3 cos 2x plus 1 was equal to 4 cos squared x minus 2 sine squared x. If I divide this by 2 then, I would get 2 cos squared x minus sine squared x. So let's just do that to start with, just so you can see what's happening. Divide by 2 on both sides. We would get 3 over 2 cos 2x minus plus a half equals 2 cos squared x minus sine squared x. But this is the opposite signs on here. So if I then divide through by minus 1, or move everything to the left hand side, I suppose, is another way to think of it. Then you get minus 3 over 2 cos 2x minus a half equals minus cos squared x minus 2 cos squared x plus sine squared x, which is exactly what I'm trying to integrate. So if I can integrate my left hand side. So my integral becomes the integral of minus 3 over 2 cos 2x minus a half dx. So that equals minus 3 over 2 cos goes to sine, so sine 2x. And you need to differentiate the 2x to get 2 and divide by 2. So I'm dividing the whole thing by 2. A half minus a half goes to minus a half x, and we've got plus c. Dividing a fraction by a number means I can just times the denominators. So we get minus 3 sine 2x over 4 minus a half of x plus c. And we're done there. Integrate a trig function with the chain rule. SQA Higher Maths 2016 Paper 1 Question 5. Integrate 8 cos 4x add 1 dx. Cos goes to sine, check the start of exam paper, so that equals 8 sine, the whole function 4x plus 1. But then I need to differentiate 4x plus 1, well that's 4, and divide by that. So divided by 4, and don't forget your plus c. 8 divided by 4 is 2, so we get 2 sine 4x plus 1 plus c. And we're done there. Okay, integrating a trig function again with a chain rule. We've got Higher Maths 2019 Paper 1 Question 11. Evaluate the integral between 0 and pi over 9 of cos 3x minus pi over 6 dx. Exact value question as well, because it's non-calculator. So let's start integrating. That becomes cos goes to sine, remember. We're looking at the start of the exam paper. The whole function 3x minus pi over 6. But then we need to differentiate this. Well, that's just a number, so that's nothing. That becomes 3. So divide by 3. And that is the integral between 0 and pi over 9. So there's our first step. Now we need to just substitute in. So that gives us a third of sine, well, 3 times pi over 9, we'll just write, minus pi over 6. That's our first one. Take away our second one, subbing 0 in. So that's a third. Sine 3 times 0 minus pi over 6. Okay, so we can now we'll just tidy it up, put an extra bracket on. We can now just evaluate that. So that gives me 1/3. If I take my first one, sine 3 pi over 9. So let's just do this. 3 pi over 9 is pi over 3. So I've got pi over 3. And then our pi over 6, we can think of that as minus pi over 6. Take away 1/3 of sine. And then 3 nothings is nothing, so it's just minus pi over 6. So that gives me 1/3 of the sine of, well, pi over 3 is 2 pi over 6, minus pi over 6 is pi over 6. So we've just got pi over 6 now. Take away 1/3 of the sine of minus pi over 6. So we're going to have to work out what the sine of pi over 6 is. So if you're thinking in degrees, pi over 6 is the same as 180 over 6, which is 30 degrees. So exact value triangles is how I always think of this. So if I got myself a triangle with 2 on this side, 1 on that side, then by Pythagoras, 2 2s is 4, minus 1 is 3, that is root 3. Now that was 60, so that one's 30. The sine of 30 degrees is equal to a half. You might have just memorised that yourself. If you think of a sine graph or a cast diagram, you can see that minus 30 would be about here. It's obviously minus a half for the sine of minus 30 degrees. 1/3 of the sine of 30, so 1/3 times a half, minus 1/3 times minus a half. So 1/3 times a half is a sixth. 1/3 times minus a half is minus a sixth. So plus another sixth because of minus times a minus. That is 2/6. That is 1/3. And we're done there. Okay, integrating with the chain rule, not a trig function this one. 2017 paper 1 question 13. Integrate this function, so we need to get it ready to integrate first. So that becomes the integral of 5 minus 4x to the minus a half dx. It's telling you obviously that x can't be less than 5 over 4 because this would be not valid. Now, let's integrate that. So we add 1 to the power. So we get 5 minus 4x to the power of a half. We divide by the new power. So divide by a half. But we also divide by the function differentiated. So times minus 4 on the bottom as well. And we've also got plus c, of course. So that gives me 5 minus 4x to the half. A half times minus 4, well, minus 4 divided by 2 is minus 2, plus c, tidying that up, put my minus on top, that gives me minus a half of 5 minus 4x to the half, plus c, and you would be fine just stopping there. Integrating with a chain rule, SQA Higher Maths 2018, paper 1, question 14, find the integral between 9 and minus 4 of this function. Going to have to get it ready to differentiate first, so we've got between minus 4 and 9, 1 over, so it's the cube root, so that's to the power of a third, but it's squared, so it's to the power of 2/3. So it's 2x plus 9 to the power of 2/3 dx, which equals the integral between minus 4 and 9, taking it up to the top, 2x plus 9 to the minus 2/3 dx. And now we can integrate it. So we add 1 to the power and divide by the new power. So being very careful, we've got 2x plus 9. Add 1 is a third. Divide by our new power. So divide by a third, but also divide by this differentiated, which is 2. So I can say times 2 on the top bottom as well. And that is between minus 4 and 9, which I'll substitute in when I'm ready. Now this is a non-calculator question, so I'm going to have to put it back into root form as well. So that gives me 2x plus 9 cube root. So I can just write the cube root of 2x plus 9. 2 times a third is 2/3. And that's between -4 and 9. Almost done. Dividing by a fraction means we can times it by the reciprocal, flip it upside down in other words. So we get 3 times the cube root of 2x plus 9 over 2 between -4 and 9. And now I'm ready to substitute my numbers in. So substitute 9 in, take away, substitute -4 in. So subbing in my numbers, get 3 times the cube root of 2 times 9 plus 9 all over 2. I'll just put that in big brackets. Minus 3 times the cube root of 2 times -4 plus 9. I'll just make that clear that that's separate, all over 2. And now we can work some of that out. So that's 3 times the cube root of 2 9s is 18, 18 and 9 is 27 over 2, minus 3 times the cube root of 2 times -4 is -8, and 9 is 1. All over 2, and that's handy because that now simplifies quite easily. The cube root of 27, 3 times 3 is 9 times 3 is 27. So this just gives me 3 times 3 over 2 minus cube root of 1 is 1. 3 times 1 over 2. That equals 9 over 2 minus 3 over 2, which equals 6 over 2, which equals 3. And we're done there. SQA Higher Maths 2022, Paper 1, Question 6. Integrate between -5 and 2, 10 minus 3x to the power of -1/2 dx. Okay, let's start working on this. So we've got the integral of -5 and 2 of 10 minus 3x to the power of -1/2 dx. Well, we can start to integrate this by adding 1 to the power. So we've got 10 minus 3x to the power of 1/2. We then need to divide by the bit inside the brackets differentiated. So inside the brackets is 10 minus 3x. If we differentiate that, you get -3. So we need to divide by -3, or in other words, that's the same as times it by -1/3. You get your first mark for just starting to do that, and you get your second mark for showing anywhere that you are going to be dividing by -3 or timesing by -1/3. So there's your first 2 marks there. And then we need to process our limits. So let's tidy this up a little bit before we get to that. So we get 10 minus 3x to the power of 1/2. Dividing by 1/2 is the same as timesing by 2. We've got a minus because of the timesing by -1/3 divided by 3. Now, our limits are 2 and -5. So we've got -2, 10 times -3 times 2 to the power of 1/2 divided by 3. There's our first limit, and that is -2, 10 minus 3 times -5 to the power of 1/2 divided by 3. So there's our 2 limits because it's between -5 and 2. So your third mark is actually coming in at this point. For substituting in 2 and -5 and putting the minus in between, you are getting that mark. So there's your third mark there. And then your final mark is for actually working that out. So let's work that out now. Just being very careful. So we've got -2, 10 minus 6 is 4. So it's times the square root of 4, because to the power of 1/2 is square rooting, divided by 3, and that's minus. And then we've got -2 again. 10 minus 3 times -5. That's -3 times -5 is 15. So that's 10 add 15, which is 25. So it's times the square root of 25 over 3. Working out that, we get minus 2 times 2, which is minus 4 thirds, minus 2 times 5, which is minus 10 thirds, minus 4 plus 10 is 6, so that's 6 thirds, which is equal to 2 in the end. So if you can get down to getting 2, there's your final mark there for working that out. Okay, let's go through some key points of where you could go wrong in this question. If you differentiated and didn't integrate, unfortunately you get no marks at all, even if you're substituting numbers in. There's no way to get any marks for that. If you start to integrate individual terms, if we go back to the standard, the actual question, if you're trying to integrate, say, the 10 to get like 10x, and then the minus 3x to get something like minus 3 over 2x, you're just doing it inside the bracket, or you're trying to expand the bracket, you can't get any more marks after that as well, because it's just invalid, it doesn't work. For mark 4 down here, it's only available for non-integer power. So in other words, if your power here, I've got a half as the correct answer. If you'd use squared or cubed or 4, that we wouldn't get a mark because we're checking if you can do the third part as well. Differential equations, SQA Higher Maths 2015, paper 1, question 15. The rate of change of a mug of coffee is given by this differential equation. It tells you some information. Express t in terms of t. What you need to realise is if you integrate a dt by dt, you just get t back. So we can just immediately say that t equals the integral of the right hand side, 1 over 25 t minus k, and that will be with respect to t because it's dt instead of dx as normal. So we'll just integrate and let's go. So we get 1 over 25 t squared, and then we times by a half because we divide by 2, and then minus k times t, but then we've also got plus c. So there is our integral. Let's just tidy that up. Dividing by a half, we get 1 over 50 t squared minus kt plus c. So there's our initial step, but then we need to eliminate that c, but luckily we're given some information. It says initially the temperature of the coffee is 100 degrees. 10 minutes later, the temperature has fallen to 82 degrees. Express t in terms of t. So, first step, we know that initially, when t is 0, the temperature is 100. So we can say that when t equals 0, big T equals 100. Subbing all that in, we get 100 equals 0 minus 0 plus c. In other words, c equals 100. So we've now got t equals 1/50th of t squared minus kt plus 100. But we need to find this k, so we've got an extra bit of information. 10 minutes later, the temperature is 82. So in other words, when t equals 10, big T equals 82. Subbing that point in, we get 82 equals 1/50th of 10 squared minus k times 10 plus 100. So we just need to solve and get k back out. 82 equals 100 over 50 minus 10k plus 100. Just quickly running through this, you get 2 minus 10k plus 100. So you get 82 is 102 minus 10k. Moving the 10k over to this side to make it positive. That is 102 minus 82 is 20. So k is 20 over 10, which is 2. So our final answer is just t is equal to 1/50th of t squared minus 2t, because k is 2, then plus 100. And we're done there. Differential equations, SQA Higher Maths 2016, paper 2, question 9. For a function f defined in a domain, suitable domain, f dash x is equal to this, and f of 9 is 40. Express f of x in terms of x. So again, it tells us that f dash x equals that. So if I integrate, I'm going to get f of x. So I just integrate the right. So I can just straight away say that f of x is the integral of 2x plus 1 over root x dx. Now I need to get that ready to integrate, sorry. So that is the integral of 2x plus 1 over x to the half dx. I can split that up into two separate fractions, 2x over x to the half plus 1 over x to the half dx. Integral of, so if that is a 1 power, 1 minus a half is just a half, so this simplifies to 2x to the half, and then that's plus x to the minus a half dx. So we can now integrate it, add 1 to the power, so we get x to the 3 halves. We've still got the 2, and we're going to divide by 3 halves in a minute. And then add 1 to the power of this, we get x to the half, divide by the new power, so divide by a half, but then we've got our plus c. Remember, this is f of x. Tidying that up a little bit, f of x is equal to, dividing by a fraction means that this times by its reciprocal, so I do 2 times 2 is 4 over 3. So that's 4/3 of x to the 3 halves. And 1 divided by a half is 2, so plus 2x to the half plus c. So there's our initial point, but then we need to find c because we're given some information. So we know that f of 9 equals 40. So in other words, that tells us that when x equals 9, f of x or y equals 40. We can just sub that in. So we get 40 for f of x equals 4 over 3. Now I'm going to change the x to the 3 halves to the square root of x cubed. So the square root of 9 cubed. And plus 2 times the square root of 9 plus c. Because this is actually, it's not a non-calculator, it's a calculator paper, but you can do it with a calculator really. So 40 equals 4/3. The square root of 9 is 3, so that gives me 3 cubed coming out. Plus 2 times 3 plus c. Now use a calculator anytime you want. 3 cubed is 27 divided by 3 is 9. 9 4s is 36. 2 3s is 6 plus c. So we get 40 is 42 plus c. And therefore c is equal to -2. So then we can express our f of x. F of x is equal to 4/3 x to the 3 halves plus 2x to the half, and it was plus c, so -2. Or if you've already changed it all, f of x is equal to 4/3 of the square root of x cubed plus 2 times the square root of x minus 2. Either of the options would be fine. Differential equations, SQA Higher Maths 2018, paper 1, question 10. Given that dy by dx equals this, and y is 14 and x is 2, find y in terms of x. So dy by dx equals that, so if I integrate dy by dx, I get y back. So I can immediately say that y equals the integral of the left-hand side, 6x squared minus 3x plus 4 dx, and that's nice and easy. Want to do, add 1 to the power, divide by the new power, minus 3x squared over 2 plus 4x plus c. Also remember your c. Tidying that up, y equals 2x cubed minus 3 over 2x squared plus 4x plus c. But we're told that when y is 14, x is 2. So when y is 14, x equals 2. So we can sub it in to get 14 equals 2 times 2 cubed minus 3 over 2 times 2 squared plus 4 times 2 plus c. Now this is a non-calculator paper, so you just have to do this all manually. So 14 equals 2 2s are 4 times 2 is 8 times 2 is 16. 2 2s are 4 divided by 2 is 2 again. 2 3s is 6, so that's 6. 4 2s is 8, and then we get a c. 14 equals 16 minus 6 is 10, 10 add 8 is 18 plus c, and therefore c must equal -4. And we're done for c, so we just then say that y equals whatever we got before, 2x cubed minus 3 over 2x squared plus 4x, and then our c minus 4, and we're done there. So equations SQA Higher Maths 2019, paper 2, question 13. A function defined a set of real numbers. It is shown that the rate of change of f with respect to x is given by this equation. The graph of y equals f of x crosses the x-axis 7, 0. Express f of x in terms of x. This question, I suppose, is asking you about do you know what rate of change is? Well, rate of change means differentiation. So we know that f dash x equals 3x squared minus 16x plus 11. So that means that f of x is the integral of this. And we'll get to the second bit of information to get c in a minute. So integrating that, we get x cubed times 3 over 3 minus 16x squared over 2 plus 11x plus c. So there's our initial step. We can simplify that in a moment. But it tells us that the graph of y equals f of x crosses the x-axis at 7, 0. Well, 7 is x and 0 is y. So we can substitute 0 and 7 into our equation. So we've got f of x, tidying it up, equals x cubed, minus 16 over 2 is 8x squared, plus 11x plus c. So when x is 7, y is 0. When x equals 7, y, which equals f of x, equals 0. So subbing that in, we get 0 equals 7 cubed minus 8 times 7 squared plus 11 times 7 plus c. This was a calculator paper, so you could do all the sums in a calculator, but 7 cubed is 343. 7 squared is 49 times 8 is 392. 11 sevens is 77. And then we've got plus c, and 0 equals this. Tidying all that up, we get 0 equals 343 minus 392 plus 77 is 28 plus c, and therefore c must equal negative 28. We've got our c, so we'll just sub it back into the equation we just found above. So therefore f of x is equal to our x cubed minus our 8x squared plus 11x minus 28. And we're done there. Mr. Clare here from Clare Maths. Today we're going to be looking at a paper 2015, paper 2, question 4 of the SQA Higher Maths exam paper. Let's jump straight in. Okay, this one was about a wall plaque made to commemorate the 150th anniversary of the publication of Alice in Wonderland. Okay, so the edges of a wall plaque are modelled by quadratic functions, and there's 1, 2, 3, 4, and it gives you 4 bullet point equations. So what makes this one difficult is it'll give you all these equations, all this information, but you just need to keep your head. So let's look at part A. Find the coordinate of the point of intersection of the graphs of y equals f of x and y equals g of x. So point of intersection means simultaneous equations. So the two ones I need are this one and this one. Since that would equal y and y, so I can just make both of these equal to each other. So to get 1 mark for part A, I'll just do here. I can just write a quarter x squared minus a half x plus 3 equals a quarter x squared minus 3 over 2x plus 5. And that'll give you your first mark. Okay, now we need to solve that to get the x part. And it only asks for the x part, so that's good. Notice if you've got the same thing on both sides, they just automatically cancel. So immediately I can just get like a red pen or something and go, that's the same as that. Same sign and everything, so I can cancel them. I've got minus a half x, so I can add 3 halves x to both sides. And that will get rid of it on this side. So let's just do that and do it in stages. 3 halves take away 1 half is 2 halves, which is 1. So that just gives us x left on this side plus 3 equals 5. And then we can just solve that to find x. Take away 3, so x equals 2 is unlikely as it seems our answer. Part B says the graphs of f of x and h of x intersect on the y-axis. The plaque has a vertical line of symmetry. Calculate the area of the wall plaque. you should know a power word for integration is area. So if it says area, you need to integrate and you need to find the two limits. So we've already got our first limit, it's 0. We need to know this one. Well, this one is going to be the same as this one, which you worked out in part A, where these two intersect, was 2. So that's just 2. So I need to do the integral of the upper f of x minus the lower h of x between 0 and 2. So making sure you copy it down properly, it's the integral between 0 and 2 of f of x, which is a quarter x squared minus a half x plus 3. Put that in brackets, take away h of x, which is this one, 3/8 of x squared, minus 9/4 of x plus 3 dx. So at that point you may be wondering, well, how much marks do I get? Well, at that point you get a mark for knowing to integrate, so using the integration sign, just that, another mark for putting in the limits 0 to 2, and then another mark for writing down the two curves taken away from each other. So 3 marks for literally doing no work. It's not bad, that. And then we need to integrate it, and you actually only get 1 further mark for the integration. So all the tidying up you're going to do now, you're not going to get any marks for, but you still need to do it to be able to integrate. So let's tidy this up. So that gives us the integral between 0 and 2. You've got a quarter x squared minus 3/8 x. So a quarter is 2/8. So being very careful, you've got 2/8 minus 3/8. You've got minus an eighth of x squared. Looking at the x parts, you've got minus a half minus minus becomes plus, so plus 9/4. Well, putting a half into quarters is 2/4, so you've got minus 2/4 plus 9/4 is 7/4. So plus 7/4 x. And then we've got our number parts, but they cancel. 3 take away 3 is nothing. So we get the integral of this between 0 and 2. And then we need to integrate it. So that gives us x cubed. Add 1 to the power and divide by the new power. So 3 times 8 I need to do, which is 24. And then plus x squared. I've got 7 still. But I need to divide by 2. So I've got 4 already on the bottom. So 4 times 2 is 8. And that's between 0 and 2. So that gives us another mark at that point. So let's move on and substitute our limits in. So we've got minus 2 cubed over 24 plus 7 times 2 squared over 8. Take away minus 0 cubed over 24 plus 7 times 0 squared over 8. Okay, so we get a mark for our substitution. And then we need to evaluate it to get another mark. So we could use a calculator at this point because it is a calculator paper, but I'll just go ahead and do it without. So we've got 2 2s are 4 times 2 is 8 over 24, so minus 8 over 24. And then the other number, 2 2s are 4, 4 7s is 28, so you get 28 over 8. And luckily, you've substituted 0 in here, so that is a big fat 0 for this. 0 cubed is 0, over that is still 0, 0 squared is 0, over that is still 0. So you just need to work out these fractions. So I can simplify the fractions. Well, actually, I'll add them first before I simplify because it'll be easier to see. So minus 8 over 24, and then we've got 28 over 8, 8 threes is 24, so times them by 3. I get 3 times 20, so we get 84. So now we can add them. 84 take away 8 is 76 over 24. Simplify that because you have to always have simplified answers. So I'll just divide through by 2 to get 35, 36, 37, 38 over 12. Divide them by 2 again to get 19 over 6. And 19 is a prime number, 6 doesn't go into it, so 19 over 6 is our final answer for another mark. And feel free to do that in any way you want to get 19 over 6, but that isn't the answer. You need to check your question, calculate the area of the wall plaque. Well, we have calculated the area from here to here. So all that bit, if I was to draw a line down here, but you can see it's symmetrical. It even tells you it's symmetrical. So the area of the wall plaque is double the area I just found out. So our final area, just to get our final 7th mark, the area, or like total, equals 19 over 6 times 2. 2 times 19 over 6, well, that's the same as 19 over 3. So 19 over 3 is our final answer for our final last mark. Okay, integrate and find area. SQA Higher Maths 2016, paper 2, question 3. Show that x plus 1 is a factor and then solve the equation. So that's not integration at all, but we'll do it for the sake of completeness. And then part B says, the diagram below shows the graph of this equation. Write down the coordinates of point A and B and then calculate the shaded area in the diagram. So we're going to have to do part A to get the coordinates anyway. So part A, show that something's a factor. We can use synthetic division. So for part 1, I'll set up my synthetic division nice and quickly. I've got 2 minus 9, 3 and 14. And we're trying to show that x plus 1 is a factor, so I can sub in minus 1. So I've got 2 minus 2 minus 2 minus 9 is minus 11, times by minus 1 is 11, 11 and 3 is 14, times by minus 1 is minus 14, we get 0, and we'd need to write a little statement, the remainder equals 0, therefore x plus 1 is a factor of f of x. Part 2 of this says to solve the equation then, well, we've now got x plus 1 is a factor, and we've got what's left over, 2x squared minus 11x plus 14, so that equals 0. We should be able to factorise this, hopefully. We've got double brackets, it must be 2x and x, 7 and 2 make 14, so minus 2 times 2 is 4, and then 7 equals 11, so minus 4 minus 7 is minus 11. So we've got x equals minus 1, or x equals 7 over 2, or x equals 2. Part B, the graph cuts the x-axis at A, B and C, right down the coordinates of A and B. Well, we've just worked it out. Our smallest x is A, our next smallest is B. So in other words, A equals minus 1, 0, and B equals 2, 0, and C would be 7 over 2, 0 as well. Part 2 of B, calculate the shaded area. Well, that's integral between these two numbers of our original equation. There's our equation, so it's the shaded area is the integral between minus 1 and 2 of 2x cubed minus 9x squared plus 3x plus 14. So we integrate and solve. So that equals, add 1 to the power, x to the 4 over 4, minus 9x cubed over 3, plus 3x squared over 2, plus 14x, and that is between minus 1 and 2. We then get a mark for subbing in, so let's just sub in our numbers. So tidying this up, that's a half of 2 to the power of 4. 9 divided by 3 is 3, so that's minus 3 times 2 cubed, plus 3 over 2 times 2 squared, plus 14 times 2, so that's our first one, big brackets around it, minus our second one, so that's a half, minus 1 to the 4, minus 3, minus 1 cubed, plus 3 over 2, minus 1 squared, plus 14 times minus 1. And quite often after this point it gets a little bit messy, but you're getting another mark just for solving that. But if you can get this far, you're doing really well. So let's just try and get this really tidied up. Dealing each one separately, 2 2s is 4 times 2 is 8 times 2 is 16. 16 divided by 2 is 8. So we get 8 for our first term. 2 2s is 4 times 2 is 8. 8 3s is 24. So our second term is minus 24. 2 2s is 4. 4 divided by 2 is 2 times 3 is 6. So we get 6. And then 14 times 2 is 28. So there's our first bracket. minus. Minus 1 to the 4 is 1, times a half is a half. Minus 1 cubed is minus 1, times minus 3 is plus 3. Minus 1 squared is 1, times 3 halves. And we've got minus 14 on the end. Now, you can use a calculator for most of the work on this. I would leave fractions as fractions, but none of this is going to end up being fractions anyway. That equals, using a calculator, tidying up our first bracket, we get 18. And our second bracket, we get minus 9. So it's minus 9. That equals a final answer of 27. So it's 27 as our shaded area. And we're done there. Integrating to find the area. SQA Higher Maths 2017 paper 1 question 10. Two curves with equation x cubed minus 4x squared plus 3x plus 1 and x squared minus 3x add 1 intersecting a diagram. Calculate the shaded area. To do shaded area between two curves, it's the upper curve minus the lower curve between the x's, which is 0 and 2. So I can immediately write down it is the integral between 0 and 2 of our upper curve minus our lower curve dx. So we can tidy that up before we integrate. 0 and 2, we've only got an x cubed term, and then our x squared, 4 minus 1 is minus 5x squared. Our x terms, 3x minus 3x is plus 6x, watch your signs, and then 1 minus 1 is 0. So we get this integral to do. So that is x to the 4 over 4 minus 5x cubed over 3 plus 6x squared over 2 between 0 and 2. That's x to the 4 over 4 minus 5x cubed over 3 plus 3x squared between 0 and 2. So we can now substitute our numbers in. So that gives us 2 to the 4 over 4 minus 5 times 2 cubed over 3 plus 3 times 2 squared. There's our first bracket. Minus, and it should be clear that it's going to be 0, but just for the sake of completeness, 0 to 4 over 4 minus 5 times 0 cubed over 3 plus 3 times 0 squared. All that stuff separately is 0. So we're just left with our top bracket. 2 2's is 4 times 2 is 8 times 2 is 16. Divided by 4 is 4 for our first term. Second term, 2 cubed is 8. 8 5's is 40, so we get minus 40 over 3. And 2 squared is 4 times 3 is 12. Tidying that up, we get 16 minus 40 over 3. Non-calculator, easiest way to deal with that is mixed numbers, I would say, because 3 times 13 is 39, so minus 13 and a third. 16 minus 13 is 3, minus an extra third is 2 2/3. And we're done there. Part B says the line passing through the points of intersection of the curves has the equation y equals 1 minus x. What fraction of the shaded area lies below the line? So we need to work out what the integral is below the line and see what fraction of the whole that is. You should be able to guess what the answer should be just by looking at it, but you can't guess. You have to do it. So we're doing the integral of between 0 and 2. Our upper function is the line this time, so 1 minus x. Take away. The curve below the line is x squared minus 3x plus 1. dx. Alternatively, you could have done this minus a line and then with a fraction left over to make a complete whole. It's your choice. But I'm going to do it this way. So that gives me the integral between 0 and 2 of 1 minus 1 is 0. I've got minus x minus 3x. So that's 3x minus x is 2x. Then I've got minus x squared as well. So you get 2x minus x squared, a nice simple function to integrate. So that gives you 2x squared over 2 minus x cubed over 3. Between 0 and 2, that gives you x squared minus x cubed over 3. Between 0 and 2. So substituting 0 in, we get 2 squared, 2 in, so we get 2 squared minus 2 cubed over 3. Take away 0 squared minus 0 cubed over 3. That gives me 4 minus 8 thirds. That's 4 minus 2 2/3. That is 4 minus 2 is 2. Take away 2/3 is 1/3. So 1 1/3. But if you go back to our original question, the total area was 2 2/3. Remember, our total area was equal to 2 2/3. It should be obvious that that is a half. So therefore, a half of the area is below the line. And we're done there. Integrating to find area. SQA Higher Maths 2018, paper 2, question 1. Nice simple one here. The diagram shows this curve. Find the calculated shaded area. So it's the area between -1 and 3 of this minus the x-axis, so just this. So it's the integral between -1 and 3 of 3 plus 2x minus x squared dx. So that gives me 3x plus add 1 to the power, divide by the new power, minus add 1 to the power, divide by the new power, between -1 and 3. Tidying that up, 3x plus x squared minus x cubed over 3 between -1 and 3. You've got most of the marks so far. We just need to sub in our numbers now. So we get 3 times 3 plus 3 squared minus 3 cubed over 3. Take away 3 times -1 plus -1 squared minus -1 cubed over 3. 3 threes is 9. 3 threes is 9 again. 3 cubed is 27, divided by 3 is also 9. So our first bracket becomes this, minus our second bracket, minus 3, -1 squared is +1, -1 cubed is -1, times -1 is +1. So we get to here quite quick. 9 plus 9 minus 9 is just 9. Minus 3 plus 1 is -2. Plus a third. I'll take my time on this. So we get 9 minus 2 plus a third is -1 2/3. 9 plus 1 2/3 is 10 2/3. And we're done there. Okay, integrating to find area. SQA Higher Maths 2019, paper 1, question 8. The graphs of y equals x squared plus 2x plus 3 and 2x squared plus x plus 1 are shown. They intersect at -1 and 2. Express the shaded area as an integral. So it's leading us through this one. Remember, to get our shaded area, it is the upper curve minus the lower curve. So just tracing this, there's my upper curve there, which is this one, and there's my lower curve there. So I do the integral between -1 and 2 of this minus this. So for part A, it's the integral between -1 and 2 of x squared plus 2x plus 3 minus 2x squared plus x plus 1 dx. Tidying that up, so -1 and 2. X squared minus 2x squared is minus x squared. 2x minus x is plus x. 3 minus 1 is 2 dx. So part A is done. Part B says calculate the shaded area. So work that out in other words. So for part B, our integral equals add 1 to the power, divide by the new power, plus x squared over 2 plus 2x, all between -1 and 2. Subbing in our numbers, we get minus a third of 2 cubed plus 2 squared over 2 plus 2 times 2. That's our first one. Take away minus a third times -1 cubed plus -1 squared over 2 plus 2 times -1. Okay, so then we need to work on this. So 2 2s is 4 times 2 is 8. So we get -8 thirds for our first bracket. 2 2s is 4, divided by 2 is 2, and 2 2s is 4. So there's our first bracket. And our second bracket, minus 1 cubed is minus 1, times minus a third is just a third. Minus 1 squared is 1, so that's a half. And we've got minus 2. So we've got some fractions to deal with, and it was paper 1, so we're just going to have to keep going. Minus 8 thirds plus 6 minus, I'll just times them together to get 6. 2 and 3 is 5. So we get this. I will now just take the brackets away. Minus 8 thirds plus 6 minus 5 sixths minus plus 2. Putting the numbers together, you get 8. And I've got minus 8 thirds and minus 5 sixths to deal with. That's 8. Doubling 8 is 16. So that's 16 over 6 minus 5 over 6. So that gives me 8. 16 minus 5 is minus 21 over 6. Changing that to a mixed number, 8, 6 threes is 18. And 3 sixths. Simplifying, 8 minus 3.5. 8 minus 3 is 5. Minus another half is 4.5. Don't worry about all that extra substitution and what you need to do. You get most of the marks for getting to the point of substituting in. Okay, so don't worry if you can't get that far.
Question 4 says the graph has an equation x cubed minus 5x squared plus 2x plus 8. The total shaded area bounded by the curve and the x-axis. We've got this area here and this area here. In the first part of the question, calculate the shaded area above the x-axis. So between minus 1 and 2. So for part A, we need to integrate between minus 1 and 2 our function x cubed minus 5x squared plus 2x plus 8 dx. And that'll give us the area. So x cubed becomes x to the power of 4 over 4 minus 5x cubed over 3 plus 2x becomes x squared divided by 2 still x squared plus 8x, and we're doing that between the limits of minus 1 and 2. So we need to substitute 2 in, take away, then substitute minus 1 in. So for our first bracket, we've got 2 to the power of 4 over 4 minus 5, 2 cubed over 3 plus 2 squared plus 8 times 2. Take away our second bracket, minus 1 to the power of 4 over 4 minus 5 minus 1 cubed over 3 plus minus 1 squared plus 8 times minus 1. So let's work out each bracket separately, and I'm going to keep it as fractions so that our answers is nice as possible. I'm just using my calculator to get those fractions. So our first one, we have got 4 for the first term minus 13 thirds plus 4 plus 16, and we're taking away a quarter plus 5 thirds because it's minus times a minus plus 1, take away 8. So for the first bracket, we would get 10 and 2 thirds minus the second bracket, which is minus 5 and a 12. So adding them together, you would get 15 and 3/4 units squared as our area. Part B then says, hence calculate the total shaded area. So we've already got this bit, so we just now need to work out the integral between 2 and 4. And just a reminder, when you're wanting to work out an area when it's below as well, you would do this one, take away this one, and that will give you your total area. So for part B, we've got our integral already between minus 1 and 2 of x cubed minus 5x squared plus 2x plus 8. And we're going to take away the integral between 2 and 4 of the same thing, x cubed minus 5x squared plus 2x plus 8 dx. Just put that bit in brackets just to separate it out. And I'm going to do that bit first. I already know the answer to this bit. Let's just write that down. So that gives us 15 3/4 minus, let's just start integrating now. So we already know the answer to that, so there's no extra work required. It's a quarter x to the 4 minus 5 over 3x cubed plus x squared plus 8x, and that's between 2 and 4. So keeping that 15 3/4 just floating about, minus, let's just use big brackets. Let's substitute our 4 in to start with. So we end up with 4 to the power of 4 over 4 minus 5 times 4 cubed over 3 plus 4 squared plus 8 times 4. So that's our first limit. Take away our second limit, which in this case is 2, so it's a quarter, 2 to the power of 4 minus 5, 2 cubed over 3 plus 2 squared plus 8 times 2. 15 3/4 minus, the first bracket, it's 64 minus 106 2/3 plus 16 plus 32. That's this bracket here. In this bracket we already know the answer to because we did it in part A, so we might as well just write down the answer. That was 10 2/3. So take away 10 2/3. (15 3/4) minus, first part of the bracket gives you 5 1/3 minus 10 2/3. So that means our area is 15 3/4 minus the answer to this, minus 5 1/3. Minus, minus, so we're adding them together. So 15 3/4 plus 5 1/3 gives us a final answer of 21 1/12 units squared.
SQA Higher Maths 2015, Paper 1, Question 12. Some unusual integration questions or some harder ones. So the diagram shows the graph of y equals a cos bx. The shaded area is a half. So we know that this is a half. What is the value between 0 and 3 pi over 4? This is checking if you understand graphs and also understand the symmetry in a sine graph. So if we know that that's a half, if I draw a little line here, we know that that's also a half, and therefore that bit must also be a half. But it would be minus a half and minus a half because we're below the x-axis. So that means that our integral between 0 and 3 pi over 4 of a cos bx just simply must equal, well, we know that's a half as well, just to be clear, it must equal 1/2 minus a half minus a half. So a half minus a half is 0, minus another half is minus a half square units. And that's it, we're done there.
The chain rule. SQA Higher Maths 2016, Paper 2, Question 10. Given it y equals x squared plus 7 1/2, find the y by the x. And then part B, hence find the integral of this function, which we'll use our answer to part A to do. So part A, the y by the x is equal to, take the half down to the front, x squared plus 7, take 1 off the power, minus a half, and then we differentiate the bit inside the brackets, which is x squared, so that becomes 2x. So that equals 2x divided by 2 is just x, so x bracket x squared plus 7 to the minus a half. And then try to make it look a bit like our part B, that's x over x squared plus 7 to the half, which is equal to x over the square root of x squared plus 7. Part B says integrate 4x over the square root of x squared plus 7, which is very similar. So if I do part B, integrate 4x over the square root of x squared plus 7 dx, well, if I just take that 4 out, I get the integral of x over the square root of x squared plus 7 dx, which I already know is exactly the same as what I found out up here, my differential. This integrated is exactly that. So I can just write the integral as x squared plus 7 to the half. Simple as that. So that means I've got my answer is 4 times x squared plus 7 to the power of a half. Or, let's make that neater, x squared plus 7 to the half. I've forgot my plus c, so there we are, plus c, and we're done there. We move on to what I would say is unusual differentiation questions. The first one we're going to look at, just stuff that doesn't come up as often, is this one. A quadratic function is defined on a set of real numbers. This was 2017, paper 1, question 15. Diagram 1 shows the graph of y equals f of x with the turning point at 2, 3. And diagram 2 over here shows the graph of h of x, and the turning point is now 7, 6. Okay, let's see what it's asking us to do. Part A. Given that h of x is f of x plus a plus b, write down the values of a and b. So in other words, it's a graph transformation question for part A. So let's have a look to see what's happened. If we look at this point 3, well, let's just look at the turning point. 2, 3. It's clearly moved along to become 7. 2's become 7. It's moved to the right by 5. So if it's moved to the right, then a must be negative. So a is negative 5 because it's moved to the right by 5. And then our b, well, plus b on the end means it's moved. The whole thing's moved up by some number. We started at 3 and we've ended up at 6. 3 plus 3 is 6. So b is simply the number 3. And we're done there. So part B says it is known that the integral between 1 and 3 of f of x is 4. What is the value between 8 and 6 of h of x? Well, an integral means an area. So we know that the area under this bit here is 4. So that means over in this graph, since it's just moved up, this whole area here is also 4. And leaving the extra bit between 6 and 8 is just a rectangle. That is 2 along. And that must be 3 because the graph's moved up by 3. 2 times 3 equals 6. So our integral between 8 and 6 of h of x is just 6 plus 4, which equals 10. And we're done there. Part C says, given that f-1 equals 6, what's h-8? f-1 equals 6. Let's just use a different colour pen now. That means that the gradient of the tangent at this point here equals 6. And it's asking us, what is the gradient of the tangent at 8? Well, at 8 on h of x, 8 is this bit here. Now that's, if we imagine looking at this graph instead, that would be this point here. It's a mirror of this, so it's sloping down the way. So it's just minus 6, because it's just the other side of the graph. So h dash of 8 equals minus 6, and we're done there. SQA Higher Maths 2019, paper 1, question 17. Express sines x minus cos x squared in this form, and then find the integral. So it's p plus q sine rx. I'm just going to assume we need to expand the bracket. I think you should too. So we've got sine x minus cos x times sine x minus cos x. That equals sine squared x. Sine x times minus cos x, and then minus cos x times minus sine x is minus 2 lots of sine x and cos x. And then minus times a minus is a plus, so plus cos squared x. But we know that sine squared plus cos squared equals 1. So we get 1 minus 2 sine x. Cos x, we're almost there. There's no cos in this at all. But look at the start of the exam paper. Sine 2x is 2 sine x cos x. So that is equal to 1 minus sine 2x. Have we got it in that form? Well, p is 1. Q is just 1 or minus 1. And R is just 2. So yeah, we're done.
Hence, find the integral of that. So that means for part B, we can do the integral of 1 minus sine 2x dx, and that's just the chain rule. Integrate 1, you get x, minus sine integrates to cos, so plus cos 2x, but then we need to times by the 2x differentiated, so times a half, because we divide by the differentiated. Then plus c. So that is equal to just x plus a half of cos 2x plus c, and we're done there. This has been Claire Mastery. We've done the whole of integration in the SQA Higher Maths exams, especially for 2022. Hope you found that useful. Take care, stay safe, and goodbye.